Okay, so let's see. This cart's moving, and it's on a hill. So I see kinetic energy there and potential energy, right? And then it goes through these brakes here. These things slow it down. And this will be a slows it down force, right? So this energy goes to work against this, whatever that force is, right? Whatever those brakes are, it's gonna heat up its brake pads or something like that, right? Okay. And then it's presumably moving. What's the final speed's 4 meters per second, so it's also moving. Since the height is 0, we can say that it has 0 potential energy, right? And there's no springs in this problem. Now, notice that the mass, there's no mass in this term, right? So the more massive it's got, probably the more residual velocity it's got. Or no, the more force it would take. The more force it would take to slow it down to that speed, okay? So we got to put the mass in. There's a short version of that. Let's see. And then 2.15. And then that turns into a force that we don't know. And then our distance is 4.5 meters. Just a sec. 4.5 meters, and then plus 1/2, and then 15. And then the velocity is now 4 meters per second after that. So we'll put 4 squared. Okay, so now we got to do this whole thing here. We got to calculate the whole side there. So 0.5 times 15 times 5.8 squared, right? Plus 15 times 9.81 times 2.15. There we go. So this is 568.6725. And then this side here, this is F times 4.5. And then this term here is 0.5 times 15 times 4 squared. That's 120. Right? And now we're set. Now I'm going to subtract these guys, right? So this guy minus this guy. And I get 448.6725 equals F times 4.5. And now I'm going to divide by 4.5 and get my answer, I hope. 99.75. All right, 705. So 99.7, that's what we'd say. All right.